In vitro laboratories already allow parents to use genetic tests to screen their embryos not just for disease, but to choose embryos based on gender and other physical traits. BGI believes that one day there might be a test for IQ. So in the future, you're saying, yes, people may well select for intelligence.
The technology will be there.
It is one of those issues a good number of people have strong feelings about, but would rather stay away from, as it opens cans of moral, ethical, and medical concerns few believe should even be broached. But medical science and advancements have pushed this to the forefront, the discussion about designer babies, something plenty of scientists insist is more likely every day, and society needs to get ready right now. Let's welcome to Midpoint. He is considered to be one of the true pioneers in the art of cloning, and the announcement recently that he and his team had engineered the precise DNA editing at the moment of contraception in mice has the world buzzing, maybe even a little afraid. From the University of Bath in the United Kingdom, Dr. Tony Perry joins us today. Dr. Perry, thanks so much for being here.
Thank you for inviting me on.
Dr. Perry, how long have you been working on this specific idea here?
Well, not for that long, actually. It comes out of the work that we are doing, which is a much longer project, which is to try and understand how the sperm and the egg, the two gametes, when they fertilize, stop being gametes and start being an embryo. And as a result of that research, we noticed some of the properties, and other people had noticed them as well, but some of the molecular events that occur to sperm, which made us think that maybe the DNA in the sperm, the paternal genome, could be a substrate for editing.
So let's put this down into the non-doctoral terms, if you will, here, for the common man and woman here. What we're talking about here is the ability, you're not there yet, but the ability to be able to look in and basically remove certain items, certain DNA, certain strands that would lead to disease, height, weight, eye color. Give us a little bit of a thought process there.
So what we actually did, and this is my colleagues, Doctors Toru Suzuki and Maki Asami and I, was to use tools that have been developed by other groups. It's based on a primitive or highly evolved, actually, system of bacterial immunity. And these have been developed and shown to work in mammals actually within 2 years, within the last 2 years, by a group in Boston, in Harvard, in Massachusetts. And what we've done is to apply these tools at the time of fertilization. And what these tools do is they're like a kind of molecular sat-nav and a molecular pair of scissors. And the sat-nav tells the scissors precisely where to cut in the genome, and we inject them at the same time into an egg, at the same time as we inject a sperm, and so that the processes that naturally would occur in fertilization then enable these scissors, guided by the sat-nav to the precise site, to work. And what they do is they make a break in the DNA. So the DNA comes apart. And in cell biology, a double-stranded break, as it's called, like this, is anathema to a cell. The cell will die unless it repairs it very quickly, and it does. So then in the system, we just harness the natural cellular ability to repair this break, and it can use one of two methods. It can either use a kind of a bridge method, which is not the type of machinery that we actually harnessed, or it can simply stick. The second method is it can simply stick the ends together. And when it does this, it makes a small insertion or deletion of a couple of base pairs. They're called an indel, insertion or deletion. And because this has changed the coding sequence, if the cut by the molecular scissors is in the coding sequence of a gene, it inactivates the gene.
Okay, now there's where I want to stop you for a moment, because right there is it. Now we're getting down to changing people is what they're afraid of here. There's that phrase designer babies here, where people now fear what you are doing is going to allow people to change height, weight, sex, eye color, that you're going to design a child. Now, that's a scary thing, and even I'm sure as a scientist you're aware of that, and people don't want you, here's that phrase again, playing God.
Well, yes, and I think that all scientists that I know are extremely respectful of the community in which we work, which is your community. I mean, we're part of this process, and what I am interested in doing, having made this discovery in mice, is to make sure that it is discussed and that we're very open about it, so that the concerns of everyone are met. But I think there's one thing that you're saying, which is a little bit far removed from what we're doing. What we're doing, and it's all in the mouse, of course, is saying, look, we think at some point, probably in the foreseeable future, we may have the tools to do some of these things. But what we're not saying is that we know what the goal is for which these tools should be used. And even more, I think, distant, the means by which we will achieve that goal.
What is the goal?
So, well, that's one of the questions. So for me, I think that it will be very interesting to look to see whether some, for example, heritable diseases might be repaired. So if there are changes to sequences that cause distress, pain, suffering, and death, and that you have a higher chance of suffering one of these diseases. For example, there are heritable cancers. Cystic fibrosis is another example where a common mutation might be repaired. Then it might be, this is something that people might be interested in discussing. And not to take this route, at least to contemplate this route, would be a sin of omission. It's not something where we're playing God. I would say that it's more akin, if one wants to use these kind of analogies, to, in the Christian faith, to the parable of the talents. We have these gifts and we have to decide how to use them. And so that's what this discussion is about. We shouldn't bury our treasure. We should use it for the good, and we have to decide what that means.
I've got a little bit less than a minute left, and I want to make sure I get this in right now. What we're talking about here is being able to remove diseases, but at least start talking about it now so that we don't cross that line that would eventually get us to creating people.
Well, I think we need a discussion to decide where the line is. And people talk about creating people, and I heard a segment about creating intelligence and design. This is miles away. I don't know any scientific papers that will actually tell you that this or that gene necessarily predisposes to a change in IQ, that you could engineer in this way. These are very, very far off means to an end, even if we decided that that's what the end was. So I'm talking about things that are much more, I think, clear-cut and much more clearly laudable and would be acceptable to a much greater group of people. But we need to discuss this, and without having a consensus, I think it will be a problem. In order to move this forward, we need to carry everyone with us.
Let's hope we are starting the discussion here, because to be able to have diseases taken out and not have to suffer that your entire life, what a great idea for so many people. Dr. Tony Perry, thank you so much. Congratulations on your research.
Thank you very much.
Take care. Perhaps the next wave of athletic scholarships across the country with no athleticism.